Now we've talked a lot about mine life today so far, so now we're going to hear from a speaker on identifying the value of renewables across the mine life. And it's my pleasure to introduce Jean-Philippe Castonguay. He's Director of Off-Grid Hybrid Power at BBA.
Again, as Adrienne said, my name is Jean-Philippe Castonguay, well pronounced, thank you. And I'm going to take a bit of time here to introduce a bit about BBA and identifying renewable energy across a mine life. For those who don't know us yet, I'll give you a brief perspective of who we are, what we do in the industry, and dive into the subject matter, talking primarily about how to understand your operations, to be able to look at where the proper mix of renewable energy to traditional power systems fits into your operation, and then how it can be properly deployed and continuously improved across your mine life. BBA, we've been around for approximately 40 years now. We're approximately over 800 employees in consulting engineering. We have offices across Canada. Primary footholds are in Montreal area, as well as Vancouver, where we have a large office there, and Toronto, with expertise centers across Canada offering local support. So we're very much more focused on practice-centered engineering, meaning that we have a lot of in-house experts that offer tailored services to the different industry needs that we have in the markets that we focus on. And we build engineering and technical teams that gravitate around those experts to offer tailored services to the different projects that we're involved with. The industries that we work in are primarily mining, power. We have environmental services that we offer as well, now that we joined with biophilia last year, and the oil and gas industry as well, as we're highly in connection with. Briefly, not to go through all of the details within this slide, but it kind of goes to show BBA, we're involved from the very early stages of a project, from the conceptual side on the planning and the definition of a project with our clients, and then help them through the engineering, the design, building services on site, in terms of construction support and commissioning support, and then assisting into the project handovers all the way into operational optimization plans, or helping them improve on their projects. Of course, in tying into that, BBA, since we spend a lot of time on site helping our clients on their projects, it comes with a lot of hours. We're approximately close to 200,000 hours now that we clock in per year on site with our clients, which represents about 15% of our hours that we bill, which inherently becomes very important from a safety perspective. And BBA, we've been working on site since the very early stages, where we've had field engineering happening as a core service of ours, which ends up making a safety culture that is inherent with all of our employees. And since our last strategic plan, we started measuring ourselves based on the Bradley curve. And for those who don't know, it's basically a measure of how your company is mature within the safety practices. And we're no longer from an instinctive reaction in terms of keeping a safety practice, but also now we're a lot more inherent with all of our employees keep safety in mind when it comes to all of their behaviors. They're not just being supervised by safety managers, now it's a widespread culture. So in terms of the subject matter at hand, really the way I'm going to start talking about the renewable integration is starting from the definition stages all the way to defining what the proper mix of renewables are for your network. And what's most important to start looking at, and it's needless to be said, but is understanding your infrastructure. From an installed capacity, what are your peak loads? What are your major power needs for your network? And is thermal a major need for the way that you operate? Is it used in your process, or is it used for your building heating if you're in the Arctic or in high elevation areas? And these all have impacts on how you evaluate your renewable network and how they can be added to your system. And also, once you have a clear understanding of these core parts of your infrastructure, how are you planning on operating? be it a brownfield where you have a lot of understanding of how your practices are, or if it's in the planning stages, are you looking at having a very clear communication between your different groups to be able to define and plan ahead for your power infrastructure? For example, is your process plant calling in additional loads to your network? And are you able to predict when you should start up gensets or ramp up your spinning reserve to be able to manage that? And not only is that efficient and practical for your overall fuel consumption, but when you start looking at implementing renewables, you're already going to be in a practice that controls a lot more risk for your electrical network. And essentially that comes down to your operational strategy and load shedding strategy that come also very important for how you're going to plan ahead. So I'm not an electrical engineer myself. We have experts in-house that can address a little more details that's on this slide, but what I'm trying to communicate is when you start getting into renewable energies, there's a lot of electrical risks that will be inherent to bringing those onto your network. One major impact of digging in deep with renewable energy onto your network is you're going to start looking at limits and fault levels. So first and foremost, when you start defining your needs, as we discussed earlier, understanding your loads, is what do you need to keep onto your network such that you don't have any risk for your equipment or your personnel if, in terms of a short circuit part of your operation. And that'll define right away what your base load needs to be with regards to your genset or thermal power network that you're putting together. So are you going to need X amount of generators at a specific load that's online feeding your power network, and then from there it'll give you already amount of megawatts from your generator that need to be kept online, and then the rest can be complemented from a renewable perspective. Reactive power is also going to be affected, so looking at different types of equipment that need to be added to your network so that it doesn't have a risk for your loads that are going to be put online to your system, your frequency stability, and your voltage regulation, which will need to be addressed with regards to your spinning reserve strategy that you're going to have on your network to manage that, or even implementation of batteries to protect. And as well as, very importantly, in large parts, if you start digging in with renewables, you're going to potentially be reducing the heat recovery from your network that might be core to your operation. And by considering those will help you understand the financial viability of your project as well. So once you have an idea of your operation, you have an idea of the electrical limits, and you start building your business case, this is more of a disclaimer of sorts, but it's understanding your resources that's going to be used to build your financial model. And we often see clients that are very proactive. They'll set up infrastructure on site early to start collecting data, to be able to have very measured information that's specific to their location. And in some cases, they'll rely on online data. But when you start looking at online information, you get huge variability. Here's an example where about 20% of your fuel displacement will be affected depending on what source you're using that information from. And that'll have a big impact when you start looking at your financial viability. Is it bankable or not? If you don't have accurate data, you might find yourself at risk when you start implementing your project and measuring off of original plans. That's not necessarily applicable to solar. Solar satellite data is fairly accurate. But when it comes to wind, it's very terrain-specific data that you should be considering with your model. I don't think I'm adding any other information to what you know, but obviously when you start putting together your model, you'll find a sweet spot. It's very clear when you start injecting lots of renewable, you reach a point where it'll taper off in terms of the amount of fuel that you can displace for that additional dollar that you invest. And finding that area is a result of a lot of the technical viability perspectives that you're starting to look at, which we discussed earlier from an electrical standpoint, as well as the resources that are available to your network. And your unit energy cost, which is inherent to how you're going to compete with other traditional power sources, will then be defined based on where that sweet spot should be fit. And where we're kind of leading towards, and this is an over simplistic model, but if we're looking at your base load, if you're adding extra infrastructure, here is a solar example, but at some point you can add capacity, but your actual energy contribution will decrease as you start adding more installation. And of course, there's measures looking now to time shift energy to other parts of that of the graph. However, that comes with costs and will have an impact as well from your financial perspective. In terms of deployment, I think what's very important is to look at it from a scaled perspective, and I think the industry now, we're looking at attacking very low-hanging fruit, the 5, 10, 15% renewable integration, and then learning from that, and then building on additional infrastructure to help dig deeper into displacing fuel. So typically we'll try to get to know the operation with renewables as a second stage, and then continuously look to be more aggressive in sorts to how you can implement more renewables onto your network. And a lot of that is driven based on the capital cost availability. Often what we will find is when you're starting to get into a final investment decision, solar or wind power integration isn't necessarily a way of reducing thermal power sources. It's an additional cost that will basically pay itself off over time, but can be implemented later down the road. So typically, starting an operation, getting to know how your power system functions and how your operation functions, and then integrating renewables in a staged format will also reduce a lot of risk to your process plant, which ultimately is what you're trying to protect in the end run. And as your life of mine extends, as we know, a lot of the life of mines are defined based on proven resources, but the proven resources, as you continue to explore over the life of the operation, will be affected and can justify more additional infrastructure as you continue down the line. Lastly, in terms of continuous improvement opportunities, it's normal to expect conservative beginnings to protect your infrastructure and allow to learn how your operation is running. We'll often find some significant infrastructure that's put in place for renewable power, but then you're coupling it with large spinning reserve. And that comes with a cost, because all of the fuel that you're trying to displace, you're still burning it as a protective measure against fluctuations in available resources. And as you start learning your system, you'll find a way to improve, optimize your network in managing either the spinning reserve or even investing a bit more in predictive meteorology stations or battery systems to help manage those optimization measures that you can implement over time. That concludes a bit of the presentation that I want to present in terms of how to bring on different renewables. And if you have any questions or you want to know where we can assist in terms of different services throughout your mine life, please come and see us. We'll be here for the day. Thank you very much.